why do I need object orientation? This seems like the most basic of all of our questions because object orientation is just something we take for granted. It's something that just kind of shows up in our code and we learn it and maybe we picked it up from when we used Java or when we used C++ last. And it may not be clear that even though in Python everything is an object, we actually have more of an ability to decide, do we want to use explicit object orientation or not? But there is one circumstance in which we cannot avoid the Python object model. We cannot avoid object orientation. But just to remind you what we're talking about things like writing a class within an it that takes some initial state and some methods that operate on that state. And there may be some sequencing in those methods because clearly we can't do a +1 on the state if the state has become a list. So clearly we have to run F0 before we run F1. Well, it turns out that when we're using decorators, it may be the case that we want to replace the function that we're wrapping. And we want the wrapped function, the inner function, to refer to the outer function that we passed in. We want to make use of something in Python we call closures. In other words, the ability to dynamically define a function at runtime and to have that function aware of the state in the environment in which it was defined. Well, we can use a closure in order to get almost all of the benefits of encapsulation that we get from an object. In other words, here's a function, not a class definition, and it dynamically defines two functions, F0 and F1. Those dynamically defined functions are able to close over the state in which they're defined. They're able to close over this variable. They're able to refer to that variable. They're even able to change that variable. And here we need the non-local keyword. Unfortunately, we don't have time to talk about why the non-local keyword is necessary or when it's necessary or whether Python is passed by value or passed by reference or something else entirely. Maybe that's a good question for our next Python for Basics series. But what you can see here is all of the mechanics we'd expect for the class, some methods in some sequential order, some ability to get the state and some ability to set the state, can be created on this entity without the class keyword ever showing up. In other words, objects and closures form a duality. Objects, which encapsulate state and behavior, are the exact same thing as closures because closures are behavior, namely functions, or closures attached to functions, I should say, are namely the behavior, the functions, with the enclosed over state. In other words, if our goal for object orientation is to encapsulate behavior with some associated state, we do not need the class keyword at all. Dead stop, we could just write a closure. And we could see this is a little bit ugly to use. You can see we have to do object 0 to be the F0 function, object 1 to be the F1 function. But you know what? We could just return a dictionary. And we could then say, oh, object of F0 and object of F1 to refer to these individual units. Or if we really wanted to, we could even use a generator to enforce the sequencing of those operations, the F0 and the F1. And we could even have something that looks like this. Take the object, and you can see we get the state, we set the state, and then go into that generator, and then step through that. We could get all of the benefits that we traditionally get from an object. And so, if you're writing Python objects, and it's just some state with some associated behavior, you didn't need to write a class in the first place. You could have just used a closure. You could have just had a dynamically defined function that encloses over the state. So, why do we need object orientation? Well, one of the other reasons that we might need object orientation is the sequencing, but you can see with the generator example, we don't really need object orientation either. We could just write a generator. If we needed to enforce some data flow and some control flow that's operating on some shared state, that was just the coroutine that we saw. So why do we really need objects at all? Why do we need object orientation? Why do we need this class keyword? And if you look at a lot of my code, I really strenuously avoid the class keyword. I use name tuple, I use enum, I use the data class. I try very hard to avoid this boilerplate of the class. So why does this matter? Well, object orientation in Python is the extension mechanism by which we interact with the Python vocabulary. In other words, in Python, we can express a notion to a person reading our code that is a very abstract notion, like this is an entity that contains other things. Loop over it and look at each one of those things. This works on a string. It gives us each one of the Unicode code points from that string. It works on a list, gives us each element of that list. It works on a dictionary, and by default, it gives us the keys of that dictionary. Or it works on a set, and it gives us the elements of that set without any specific human ordering to them. It works on a file and gives us the lines of that file. It works on a pandas series and it gives us what does it give us on a pandas series when we iterate over on it? It's actually something not too surprising if you really think about what a pandas series is and what a pandas data frame is. In a very similar sense, if we have some arbitrary object and we want that arbitrary object to have this notion of it contains things, loop over it and look at each of the things it contains, we could write our own class using an iter and another class using an iter and a next. We could write we could make our own custom object iterable by just implementing these methods. And what you can see is Python has provided us with the vocabulary. It's provided us with a way to convey an idea. The idea is this thing contains stuff, look at those one at a time. And then we have to go and implement that idea. And how do we implement that idea? We need an extension mechanism. We need a way to tell the Python language, files are iterable, series objects are iterable, data frames are iterable, but my thing's also iterable. How do we implement it? We write underscore methods. We write these data model methods. This is what object orientation at its core is about in Python, the ability to take that Python vocabulary and to implement it, and the mechanism by which we implement it. That's all that you ever strictly need object orientation for. For example, or in other words, here we have a Python string. We can determine how big this string is. And when we determine how big this string is, it's the number of Unicode code points. We have a Python list. We can ask how big it is. It's the number of elements. We have a series. It's the number of elements in the index, or the number of individual elements it has. We have a data frame. It's the number of, for a data frame, what's the len? Is that the number of rows or the number of columns or the number of individual cells? Think about that. Maybe that's a good question for pandas basics for experts and why that makes sense. But setting that side question off to the side, here we can see, again, the notion of if we have something and we want to express the common vocabulary, how big are you, in some unambiguous, privileged fashion. And so in the data frame, there's 3 possible choices: number of rows, number of columns, number of total elements. Well, if we want to express that in a way, or it could be the number of bytes in the thing. If we want to express that in a way where it's unambiguous what that means, and there's some privileged notion to this, we have to choose one of the 4, and one of those has to be the one that wins. This is why we use the core vocabulary of Python, the built-in functions attached to their implementation with these underscore methods, their implementation through the object model. Fundamentally, when we take a look at writing our own objects in Python, it is extraordinarily tedious because if we need to instantiate something with some additional state, we need to write an init. So if I want this syntax, I need to write an init. And this syntax means create something of type T with this initial data. If I want to look at it and I don't want it to be as ugly as it looks here, I need to write a repr. I'm already tired. If I want to take 2 T objects and I want to compare them to each other, I need to write an EQ. If I need to see if one of these is less than the other, I need to write LT. If I want to see if this is greater than or equal to it, maybe I need to use functools.total ordering. If I want to add these together, I need to write add. If I want to access this thing like some sort of lookup, I need to write get item. If I want to call this thing like some sort of callable, I need to write call, and the list goes on and on and on. The amount of boilerplate needed to get an object into just a reasonable working state is probably too large for you to rapidly prototype. If you're writing these things and you have a very short amount of time and you only want to spend 2 lines of code to just get an idea in place. And as a consequence, we see things like collections.nametuple, dataclasses.dataclass, enum.enum. We see these conveniences that allow us to use object orientation in Python without all the boilerplate by saying, you know what? All of the data class objects kind of look the same. They're data classes. All of the named tuple objects kind of look the same. They're tuples with named fields. All of the enums look the same. They're kind of weird, but they are choices of singleton values that form like an enumerated set of options. Well, don't write all of that boilerplate. Just use the shortcut. It is the case that I oftentimes start my code with those conveniences and then I write the full-fledged class. But it is also the case that I often do not write that class in the first place. What I'll do is I'll say, you know what, I could implement this as a closure. That's a lot simpler. Let me go and do that. I could implement this with a generator. That's a lot simpler. But if I need to use the underlying Python vocabulary, like make this thing support the square bracket notation, make this thing addable with the plus notation, something else, make this thing sizable with the len, make this thing iterable, I have no choice but to dip into the object model and to implement it via the object model. And so to revisit one of the very first examples that we saw. Here we see 3 things that support the context manager protocol: opening a file, opening a connection to an SQLite database, working with a temporary directory. We know that the only way to implement this protocol is by writing an enter and an exit. But that's way too tedious, because once I'm writing this thing, I'm going to have to write an id and then a repr, and I'm already tired. What I could do is I could say, well, context manager is a sequencing mechanism, just like a generator. So what I'll do is I'll write a generator, and I'll put the before and the after here. And then, because I have to use the object model in order to implement this API, I'll write a class. And I'll have this class take the generator on its init. And when you call this class, it'll create a generator instance. And when you do the enter, it'll go one step through that generator. When you do the exit, it'll go one step through that generator. And because I'm too lazy to do this with all of the class mechanics, I'll use data class to remove the need to write a repr, to remove the need to write an init, to remove the need to write an EQ. I'll take this class and I'll apply it to this generator as a decorator. So it'll take this generator, load it into this class, and give me an instance of this class, because a decorator is not a function that takes a function, returns a function. It's basically a function that takes a function, returns a function, even though in this particular case it happens to be a class that takes a generator and returns an instance of that class. And this is the shorthand that I might use to implement my context manager. And in fact, this is exactly what I do when I say from context lib import context manager. When we teach our Intro to Python course, the example that I'm showing you here is one of the last examples we look at, and we look at it for a reason. All of these features and all of the syntax that we've seen and all of the built-ins that we see in Python exist as part of a coherent whole. Python is one of the few languages in the world that are focused on human intentionality and human readability. How do I express the meaning of the code that I'm writing? How do I express the intentionality? How do I express to somebody who's semi-technical or semi-invested in my problem what I'm actually trying to accomplish, minimizing all of the noise of the mechanics? And in order to accomplish that goal, I have the built-ins, which give me the ability to say, oh, I want to express the idea that this data is not order dependent. It's a set. I want to express the idea that this data can be used as a stack, a first in, first out structure, or last in, first out structure. That's a list or a collections.dec. I want to express the idea that I can unpack this thing and throw away everything but the tail. That's your unpacking syntax, your iterable unpacking syntax. I want to express the idea that I just create some data that's a list, a set, or a dictionary. But you can skim over this line if you don't really care what the data is. Write this in a way that's skimmable. That's your comprehension syntax. I want to express the idea of something that I do before and something I do after, and I'm sure that the after action is going to happen as long as before action happens. That's a context manager. I want to express the idea of some sort of state machine where there's data flow and control flow, and I can see the data flow and the control flow. That's a coroutine. Fundamentally, Python's all about giving somebody this sense of what's going on in your code, and it is a coherent design where all of these pieces come together to support this one underlying mission. We end our Python basics courses with this example because we can see here a context manager that uses a decorator, that uses object orientation, that uses a class, that uses a generator in order to accomplish the goal of not all of this mechanics, but this mechanics here with G. You have some context, something happened before, something happened after, and something happened on the inside.